Okay. Okay, there. Is it working?
Yeah.
Alright, to find the unit rate, I'm going to show you on the board once these guys are settled in, once I go through you, how I want you to set these up. And we're going to use fractions so that you can kind of use your units to help you figure out what you're going to do. Cool. Alright, ladies and gentlemen, I want to go over real quick the unit rate again, because we might be missing just a small bit of it. No, you're not wrong. I'm just going to kind of show you a trick to help you set it up correctly. When you're trying to find the unit rate, you need to compare two like things. Alright? So compare your model to your real thing. And so the like things that we had the information for is, we had our model Earth, right? And we had the real diameter of the Earth. So they're two like things, they're just scaled differently. So the way you start setting it up is you compare your model Earth, which is 12 centimeters, and you make it equivalent to the distance of the diameter in real life. So the diameter of the Earth in real life. Okay? And then here's where you think, okay, how do I get my unit, which I want to be in centimeters, because that's what I'm going to go off my model, to be 1. How do I get it down to 1?
You don't.
So I take this and divide it by 12 centimeters as well, and then our units cancel out, and what are we left with? 1. So this is 1 centimeter, or this isn't 1 centimeter, this is 1 unit. 1 unit. And what we do on one side,
You have to do the other.
we have to do to the other side. So then I'm going to put 12 centimeters under here. And now it's lining up my units correctly. Alright, so when you did this, you got 1,063. And so our units are kilometers for every 1 centimeter. Cool? Alright. This tells us that for every centimeter, it's this much. We're going to use this number to help us find the answer to these questions. What is the model moon's diameter? And what is the model system distance? Okay, so the system, by that I mean the Earth and the moon. What's the distance between them in our model? Okay, so in real life, we know it's this. Yeah? Take a minute and talk with your group about how to solve for this, and I'll come around and check with you, tell you if you're on the right path. Don't forget your units. Especially this one is tricky because it's 2 units
So
in one.
you copy this down?
Alright, ready to go?
So make sure you get your units on there. So it'd be centimeters. It'd be kilometers per centimeter. Wait, kilometers, and then that would be kilometers per centimeter. Wait, do this kilometers slash centimeters.
You got it now.
Wait, no.
Kilometers slash.
Yeah. Because then the kilometers will cancel out, and then it'll just be the centimeters. So I'll do that for every single one. So they're all the same. Did you get that yet? Or
This isn't about that.
do you have the distance between Earth and the moon?
I'd like to use your unit rate and figure out exactly.
So it should be 12 centimeters is Earth's diameter, and then 3.3 centimeters would be the moon's diameter, and then 361.2 centimeters would be the distance between Earth and the moon.
Okay, well, think about this. What did you do here to find the model? Okay, so what are you going to divide to find the model distance?
Well, you have this number divided by that.
No. That number?
And then the kilometers cancel out, so it's just centimeters.
Use your units, see if it makes sense.
I don't think that makes sense.
Well, last time we took the real diameter divided by the unit rate. So is that what you're doing now?
It's cool how they like
You're
cancel
taking a real
out.
number, dividing it by the unit rate.
So that'll be our Earth, and we'll make a moon that has a diameter of 3.3 centimeters. And then we'll need a string that's 361.2 long, right?
Yeah.
The hardest thing is probably going to be the moon, right?
So it looks like you took the real diameter of the moon and divided it by our unit rate and got 3.3 centimeters. And then you took the real distance and divided it by the unit rate and got 361.2 centimeters. Does that make sense?
Mm-hmm.
Okay. And I'm just going to see what they calculate, and then I'll tell you how to actually build the model. The nearest tenth is fine. It's 361.2. And
Okay, so we're done then, right?
yep, looks like you're done. Let's catch Peyton up. Yep, he's on it. 1,063. Kilometers per centimeter.
Not a good drink.
Alright, so something about your unit rate. 1,063 kilometers per centimeter. When you did your model moon diameter, you took 3,474 kilometers and divided it by your unit rate, 1,063 kilometers per centimeter. What this equation is saying. Yes, ma'am.
75 and 75.
Thank you. Good catch. 74. Okay. What this means is, for every centimeter, it is equal to 1,063 kilometers. And 1,063 kilometers will fit into 3,474 kilometers how many times?
361.
Wrong one.
3.3.
Okay, so this is saying, for this distance, how many of these distances do we need that will fit in here? And that represents this in centimeters. So our unit rate is the key, is the ticket to getting our model number. Cool? Then you also did the distance. So you were like, need to find the model distance. So I'm going to take the real distance, 384,000 kilometers. Okay? And you divided it by our unit rate, 1,063 kilometers per centimeter. And you said this amount will go into this how many times? What is it, 160?
361.2 centimeters.
There's no 16. It's 361.2.
361.2.
0.2.
0.2?
Yeah.
There's no
Sorry, you're right. 3.
61.2.
Fantastic, thank you. 361.2 centimeters. Okay, so this amount goes into this amount this many times. And that represents 1 centimeter equals this. We're going to be practicing. Okay? But before we practice more of the math, I want you to actually do the physical build. So this is what you need. Okay? You're going to rip off 10 inches of a sheet of tinfoil. You'll need a ruler. You're going to take the tinfoil and you're going to squish it so that it fits to our model size.
Of 3 centimeters. 3.3.
Okay. And then this one, let's pare this down to meters. How many centimeters in 1 meter? 100. 100. Okay. The beautiful thing about the metric system it goes by 100s, which means I can just move my decimal. I'm like dividing this, okay? So, yeah, 3612 turns into 3 meters, 61 centimeters, and 2 millimeters. You know what? Let's do this. Let's make life easier. We aren't dealing with millimeters. Okay, so this means meters, 3 whole meters, plus an additional 61 centimeters, plus could you add 15 centimeters on, because after you cut your string, I want you to tie it around the foil because the tape doesn't stick. So that'll help get you your extended line, okay? You need a globe. You can tape the string to the globe. You need a string. You're gonna have 15 centimeters. You need a meter stick and you need tape. Okay? Let's go.
Other tape.
You got tape?
Okay, sure. Not me.
I got big.
That's not the same as delicate.
Sorry.
You want to get a meter?
Oh, we already have straight.
They're all wrong. Last class wasn't real hot at doing this, so take it off.
Mix.
Don't start
Right?
Whoa.
Ready?
Let's do this.
I'm gonna move this.
Do you have the meters?
It's totally fine. Cecily was supposed to get the meter.
Do you want to help me?
Yeah. Checks on you for spelling words wrong. That's just mean.
Hold the end of
That's
it.
rude.
Do it.
Oh. Ironic.
No,
Okay.
It's kind of like it's
Hold it right
ironic and canny at the same time.
Put that at the end of it.
Ironic canny.
No, put that at the end of this.
The word was supposed to be
Okay, I like it. Ironic canny.
Boom. Somebody appreciates my thought.
Okay.
Did I just like
Here.
cut it off here? Because I may just roll it down.
You know what? It's just an inch. Don't worry about it. You're just gonna push it. You might need to take some off. Just push it. It's okay. I mean, I think you'll be fine.
Here. We need 61, right? Put it on there. Okay, cut. Right there. Okay.
Perfect. I can't either, but it's better than
Now tape it onto the globe.
You make me mad.
Careful, don't get it all tangled.
Did you guys measure that?
Yeah.
It's supposed to be 10 meters.
3 meters.
Does it matter which way I tape it?
I would assume you would tape it on the very top though, right? Or no, would you? Maybe not.
Haley, top or aside?
Just questioning where to tape it, Haley.
On the side of it.
Whoa.
I got this. I got this. Where's the scissors at?
You get to a certain point, it is hard, isn't it?
Oh yeah, no, wait 1 second.
That's a small book.
So this is
It's dragging on you. It's all wrapped around you. Sorry. Let's just tie it up.
I need to tie this.
Where's my meter stick?
Is that right?
We're done.
70, 76.
There you
Where's
go.
the meters?
Okay,
Plus
what?
the 50. I just
How big
added
is this right now?
61.
It's
plus
almost
50.
right.
It's close, I'd say.
I just need to squish on the sides a
Yeah.
bit.
I would say you're very close there.
Okay, now do another meter.
Did you need a lot of this?
Am I touching your finger?
There. Oh, it's so slightly bigger than it needs to be.
Okay, and
It's
then
annoying me.
I can't believe I forgot the 15 centimeters.
1 more meter.
How many meters do we have?
plus 15. So 61 plus 15 is
Meters are so big.
76.
Why don't we switch to metric
That's so
instead?
good. Yeah,
It's so much
Great
easier.
question.
Okay.
It is
Now,
really that
you
much
can use
easier.
a stick
That looks
and
nice.
then That.
Alright, tie one end around it. This is the tricky part. It's gonna take 2 people.
I just tied that little knot, so I think that'll be great.
Wait.
And then you can
I
tape it to the
One more.
globe.
Okay.
Yeah.
The scissors we forgot.
Oh, they're right there.
Why'd they shut it off?
Well, I didn't want you to come here.
Never having a bad day.
Little piece right there. Okay.
Looks like a good oh, yeah. I popped in there.
Really cool.
I mean, I can
Interventions. It's not a circle.
just tie it
but
around it.
Well, technically, the Earth is in.
Are they getting bigger?
Wait, that's not straight.
Oh my god.
It just sets up on the table. Are the babies growing?
Yeah.
There are a lot of them. They're like,
I think there's about 12.
Okay.
It's hard to so we have
other ones are chubby.
That's like you guys
Three
sit
points
then.
to go
Go
ahead
ahead
and
and extend
meters.
it in front of the camera so they can see the link.
Okay.
Good.
Keep going.
Okay, so we have the globe.
Do you guys need help? You want me to do it?
so
I have really good time. Look at that knot. Make sure you add 15 centimeters.
It won't.
Somebody has to hold it.
Okay.
What if you be able to seal it?
Okay, don't pull it tight where it breaks. So,
Can I use like?
should we scoot back more? Let's
Can
scoot back.
you angle yourself? Can you see yourself in that
Hey,
video?
so
Yes.
now we can see it. Okay. Cecily, walk my way.
Does it have to be
Cecily, walk
perfect
my way.
space?
You're not.
Well, it's not.
She's in it. She's in it.
3
Okay.
centimeters wide and
There.
That
Raise
is
it up. Raise it up.
that is huge.
Thank you for that. Yeah? Did you know we were that far away?
No.
No.
And this
Also,
is even
this is
a
tiny.
Oh,
small thing.
This is a small
This is
system,
so
yeah.
tiny.
Consider us away from the next planet or away from the sun. Or the expanse of this whole system.
We need to
Like that's not even like.
Wait. I want to see how.
Yeah, this is not to scale.
How,
That's
not
to
even
scale.
close.
I want to see that.
We're going to, but we have to go outside.
But, no, I mean like how far this is
Oh,
compared to that right now.
Well, and this Earth is bigger, so it would be even further away.
Okay, we
Yeah.
need to measure it to
Great
make
job.
sure
You guys can stop the video.